Hello everyone, welcome to another video, and in this video we're gonna solve how to find the middle of a linked list. So we will be given a linked list and we have to return the middle node of that list. This is an easy problem. Let me explain this on the whiteboard. Just assume that we have a linked list that starts from 1 pointing to 2 pointing to 3 pointing to 4 pointing to 5 and then to null. Right now it can be solved using set again, not a set but a map. What we're going to do is, for every iteration we're going to save the count and the node, like 1 1 2 2 3 3 4 4 5 5, and when it becomes null we see we have a odd length, so 5 by 2 plus 1, that is 3, and we're going to find the third node and return it. If it's a 4 node, then 4 by 2, that is second node, we're going to send the second node as middle. Simple. So this will be like OFN time complexity, and this map method will need OFN space complexity, right? But we can do it without space, just like we solve our even we know in array we can create a slow pointer and a fast pointer. Fast pointer will move by 2 index and slow by 1. By the time the fast reaches the end of an array, the slow will be at the middle, right? That is one way to find mid of an array. But in array we have length available, so we just have to make length by 2 and we can find the middle, right? So we don't have to do all of these in an array, but that is a method to find middle of an array. Here we have to implement the same pointer method in the linked list. One pointer will start from L1 and one pointer will start from L1.next, right? Let this one our L1 pointer and let this one our L2 pointer. So at next iteration our L1 will reach to, now L2 exists, so we're going to move our L2 to 2. At that time our L2 will L1 to 2. At that time our L2 will move to next, that is 5. In next iteration still our node exists, right? Then in next iteration we'll find 5.next becoming null, right? At that time it will try to move, but it will become null by the time our L1 will move to 3, and this will become to null, and we just have to return the third node when it becomes null. So that's the solution. But when it will be like a even one, for example there is only 4 nodes, it starts from L2, we don't have next, right? It will, first pointer will start from L1 here, second pointer will start from L2 here, but in next iteration, because next will not exist, because it gonna next will be null. Next will be null by the time only one, it will move one pointer. So when the length is 4, we will be getting 2 as our node. So now let's implement that with JavaScript. So we have a list, right? So let L1 equals to list. So this will become our first pointer. Then let L2 equals to list dot next. We can say like if next dot next. Okay, we have to check if it exists or not, because if there is only one kind of let's do it. if list dot next, then list dot next, or else we have to return null. Simple. So what happened now, if we get a linked list only of 2 length, we can return the first node, first list, because that will be the middle. So now while L2, right, now again we have to write the same, L1 equals to L1 dot next, right, then L2 equals to if L2 dot next, return L2 dot next, else return null. This is for the odd case, right? Because if, for example, if there is a 5 node and our node reaches, L2 reaches at 4, we will be having next, but we don't have next. At that time we want to terminate it. If we terminate it, then our L1 will return 1 node before the middle, means the third node. Now let's, that's the logic, and at the end we have to just return L1. That should do the trick, and let's test it. So if you see in test cases, I created 1 node with 5 elements, right? 1 2 3 4 5, so it should return us third node. That's what I wrote. It should return us 3 4 5, the third node. And I created node 2 with 4 elements, so it should return us the second node. Now let's run the test cases. So as expected, it is passed. It passed. So that's that. Thank you.